Alrighty. Our next section 1.2 is, like I mentioned before, we're just going to upgrade our equations that we're going to be able to solve. So we're going to get into multi-step equations instead of just one step. Now, the only difference is that we just have to be careful about the way that we actually do undo these steps. So here to solve a multiple step equation, if you can, simplify each side. It's always nice to simplify because that reduces the stuff that we have to work with. That's what simplify means. So simplify if we can or if necessary. Then we're going to use those inverse operations again. That's not going away. That's a huge key point. So keep those in mind and let's get through these notes. So I've got 5 different equations. They shouldn't take too long. First equation, well, I got into the habit of doing this before. I'm going to keep doing this. I want that vertical bar because remember, if we do any inverse operations, it's got to be on one side or the other of that. So first and foremost, we have 2.5x minus 13 equals 2. I see the variable. Remember, that's what we're trying to get alone. And I need to get rid of the stuff that's on that side. So what I'm going to do in this case is I want to get rid of this 13 first. Notice that the 2.5 is a little bit closer to the x. It's a little bit more attached by multiplication. So I want to get rid of the 13 first. I'm trying to peel away the layers, and that's going to be the outside layer. So first, I see that this is subtraction. How do we undo subtraction? Inverse operation is addition. Now, notice I'm just going to add that number, 13. I have a minus 13, and if I add a 13, they end up canceling. But what I do on one side, we do to the other. If you're not bored of me saying that yet, you haven't been paying enough attention. So, that's going to be my first step. What's left over? Did I do anything to the 2.5x? No. So I'm just going to write that. That's along for the ride in this step. Now, I had that minus 13 and plus 13. What actually happens is they cancel each other and they go away. That would be plus 0, and I don't want to write plus 0. So, equals, straight down, and now I do have a 2 plus 13. That doesn't go away, because 2 plus 13 is 15. So, that's what we're going to go with. Now, x still isn't alone. That's the point of these multi-step equations, is that we're going to have more than one step. So, I have 2.5x. The operation that's happening there is multiplication. So now, how do I undo multiplication? I already got rid of the subtraction. I'm not worrying about it anymore. I need to focus on this step's multiplication. And in order to do that, divide. So the opposite or inverse operation is division. And I'm going to divide by that number. So divide by 2.5 on both sides. Now, if I divide 2.5 divided by 2.5, that cancels and gives me 1x, because x is still there, equals 15 divided by 2.5. Do that in your calculator really quick. Let me think. You should get 6. So, if you don't believe me, take this, plug it back in. You could have 2.5 times 6, because that's my x value now, that's the solution that we found, minus 13 should equal 2. Well, I already have equals 2, so type that whole thing in your calculator, pause the video in a second, type that whole thing into your calculator, hit enter, it better be 2. If it's not, you might have typed something in wrong. So, check that out, but that does work right. So, that means your answer is 6. Voila. Next equation, there's one down, next equation is, negative 12 equals 9x minus 6x plus 15. I'm going to drop my vertical bar. Now, notice in this case, we actually have multiple things with x. That's weird, but like the previous sentence said, simplify if necessary. These guys, since they're on the same side of the equal sign, they're both on the right side, they're technically like terms, and we can combine them that way. So I'm going to do exactly what this tells me to do since it's on that side. That's 9x minus 6x. If I combine those, that's going to give me 3x. I've got plus 15 equals negative 12. And remember, please write all of this down for your own notes. It is better for you, and it makes it easier to remember this stuff in the long term. So that's been proven in a number of experiments. So now I have it down to 1x with this, or 1x term, I should say. So what am I going to do to start getting that x alone? Well, this is going to be actually a lot similar to what we did before. The x is on this side. I want to get rid of that 15 because the 3 is sort of stuck with the x. So I'm going to get rid of the 15, and that's by subtracting because I have addition here, so we're going to subtract. Subtract 15 from both sides. Now I'm going to simplify my answers and see what's going on. I've got negative 12 minus 15. Be super careful about your signs. That's a negative 12 and then minus 15. You must get negative 27. If you don't, you definitely typed something in wrong there. Negative 12 minus 15. That's going to equal. I didn't touch the 3x yet because I was trying to get rid of this term, and that's exactly what happens. It goes away. Positive 15 minus 15 cancels. Now, x is almost alone, but remember, this is 3 times x again. So 3x divided by 3 divided by 3. This is what was multiplying on the top here. To get rid of multiplication, I divide. So negative 27 divided by 3. That's going to give me negative 9 equals 3x divided by 3 is just x. So there's your answer. Negative 9 equals x, or x equals negative 9. You can switch that as if you would like to write the x value first. That's totally okay. So there is part B. Let's go to yet a different color for part C. Now, this one looks even grosser because I've got these parentheses going on and a number outside. Yell at me really, really loud. I might hear you from where you are. What do I do when I have a number outside parentheses? Yeah, I heard that one out there. Okay, so yeah, you're right. We distribute. I didn't actually hear you. 2 times 1, distribute means multiply. So 2 times 1 is 2. And then 2 times a minus x, we can almost think of that as a negative 1. So 2 times negative 1 is negative 2x. Now, that was everything inside of the parentheses, so I'm just going to write the rest for right now because I didn't do anything to it. I should really drop this down from here. Now, I've got a bunch of terms here that are on the same side. I can simplify that just like the sentence above says. So we've got 2 and a plus 3. This is a positive 2. Always look out front to see what sign it is. If there's not a negative out there, that means it's positive. So 2 plus 3 is 5. And then I've got a minus. I should note that that's basically what I'm combining, my 2's and 3's there. Now, I didn't touch the minus 2x. I didn't combine those because this doesn't have a variable. Neither of these have variables, but this one does. They're not like terms. I can't combine them. That's just how it works. Next up, I've got this negative 8. Still haven't touched that. All right, so that simplified things, and this is looking a lot nicer on this side. So now I want to get rid of the 5. Well, that's a positive 5. I'm going to subtract. Okay, so this is a weird thing, but like I was just finished saying, always look in front of your number for what sign it is. In this case, the minus sign goes with the 2x, not with the 5. And I want to get rid of the 5 because the 2 is mashed together with the x. So I'm going to subtract 5 because this is technically a positive 5 here. So subtract, do the opposite. Subtract 5 from both sides. I'm going to move over. Let's see. I'm going to move over here. I've got positive 5 minus 5. That's what canceled. And I still have my negative 2x. That's one of the trickier things that a lot of students often miss is that negative. Remember, it's tacked with the thing after it. So it's got to stay there. And that equals negative 8 minus 5. Negative 8 minus 5 is negative 13. All right. Now, I've got my negative 2, and this is times x. Notice there's no operation in between, so we know that's multiplication. in order to undo multiply, we divide. Now we divide by the number we want to get rid of, which is negative 2. X is the only thing that stays here, equals. Now you can type that into a calculator. You will end up with a decimal, which is 6.5. Or another thing I'd be really impressed with, and I would like that you would write down as well, is if you kept this as a fraction. We're going to be working a lot with fractions. We're going to get to this thing called slope-intercept form later, and fractions are actually going to be really helpful. So being able to work with these fractions and write them as such is going to be handy. So negative 13 over negative 2, your negatives cancel, because a negative divided by a negative is positive. Now, is there anything that goes between 13 and 2? Nothing off the top of my head. So that's got to be oops. So I'm just going to leave that as 13 over 2. That is a simplified form, and it is the same as 6.5. It will work out for you, and that is going to be your answer. So I'd be really impressed if you write that, and happy if you wrote that on a test. I'm not going to mark you wrong unless I ask for a fraction specifically, but in most cases I won't. We can work with that. So there's our first 3. We've got 2 more. We're almost done. All right, last 2 problems. This time we've got x minus 2 divided by 3 equals 5. Now this looks a little weird because the x and the minus 2, I can't just get rid of that minus 2 because there's something else being applied to the whole thing, and that's the dividing by 3. Notice the entire top is divided by 3, so I can't get rid of the minus 2 first, which is a little unusual. But that being said, how do I get rid of the dividing? Hopefully you are saying in your mind, we're going to multiply by 3, because the opposite of division is multiply. So multiply by 3 on this side as well. 3 times something divided by 3, that's what ends up canceling. So the important part is the fact that the entire side is being divided by 3. So when I multiply the entire side by 3, that's what cancels. Now that's going to give me, let's see, the 3's canceled and I'm left with just x minus 2, and 5 times 3 is 15. Now we're almost done. This is only 2 steps. This is pretty easy. Get rid of that minus 2. Go ahead and do that on your own paper. You should get x equals 17, and that is your solution. Oh, pretty quick, right? Last one, part E. We do have words. Take our time through this. This is weird, though. The difference of twice a number and 7 is 9. Okay, so what we need to work on is how do we actually turn this into a sentence? Well, what does... Oops. Yeah, that's gone. The difference. What does difference mean in mathematics? Hopefully you remember that means subtraction. Now, I'm going to keep going and identifying other words that I can work with, and hopefully we can make sense of this in a second. So difference of twice. What does it mean to have something twice or twice in amount? Hopefully you recognize that means 2 times a value. So twice is always like doubling something. So 2 times a number. If we're ever just given a number, do we know what it is? Oh, I don't know what a number is, so how can I hold its value if I don't know what it is? Using a variable. So a number has got to be x. Then I've got and 7, well that's nice, that is a specific number, is. I'm going to underline is. That is one of the most important words in mathematics. I can't really say in all of mathematics, but it's a really important word, especially in this sentence. For the fact that is means equals. Well, that's huge because then we can solve an equality or an equation that we're given, and 9 just means 9. So, now, looking at this, does does what I wrote make sense to you? I've got minus, because again, difference was minus, that's not a negative. Minus 2x7 equals 9. Does that sound like any of the other equations that I've been working through? Hopefully you're saying no. How can I fix that? Well, there's a little trick that often happens when we see the difference of, or the sum of, or the quotient of. Of really means that we're going to have to move our operation to the correct spot. And I'll let you in on a little secret. It's always going to occur wherever you see the term and. And I see it right here. So the difference, meaning this sign, is really going to move to where the and is. So what's that going to look like? I have twice, meaning 2 times, a number is x, and there's my minus sign. 7 is 9, equals 9. Now, does that look like a better equation to you or what? 2x minus 7 equals 9. It doesn't really sound like minus 2x 7. Yeah, that was weird. Don't. This is how we're going to do that. We're going to look for the term of, and we're always going to move that operation to and. Now, with that being done, let's solve it. Go ahead and pause it, see what you come up with on your own, okay? Add 7. X equals 16. X equals 8. So x equals 8 should be your answer there. Hopefully you got that right. And if you have any questions, please let me know.